In example 1, we need to solve and justify. We're not going to justify these together. Please check out the videos that are prior to this lesson and you will see how to justify them. It does take a little bit of time to do, so we will just solve this one and I'll verbally tell you what I'm doing. All you need to do to justify is just write down in written form what you did to each side. Let's use the distributive property with this first one. It's a great first starting step, especially when you have this other term hanging out here. We wouldn't be able to divide by 2 because of this 7x. You could divide the 7x by 2 and also this part by 2. That would work, but it's going to be a lot easier for you, I think, if you just use the distributive property. So we've got 2x here, and then 2 times 6 is 12. Now we can combine like terms. So 7x and 2x, that's 9x. Subtract 12 from each side. 9x is equal to, looks like 18, I think. Divide by 9, and x will be 2. And you can substitute this back into the original. You've got 7 times 2, so that's 14. Here we've got 2 plus 6, which is 8 times 2 is 16. And that's equal to 30, and that checks out. In the next problem, we've got a similar situation. We want to distribute this 3 first. So we'll have 3w plus 12. Remember, there's multiplication that's indicated here. Then on the left-hand side of the equal sign, the left-hand side or the right-hand side for that matter, those are just expressions. And we can combine like terms and expressions such as this 2w and 3w, so we're allowed to do that as long as we stay on one side of the equal sign. We would not want to try to combine across, like just put this 12 and 27 together. If you're going across an equal sign, you need to do the same thing to each side, and you generally use inverses to get rid of these values here. So we got 27 minus 12, which is 15. Divide by 5, and you've got 3 for a solution. You took 3 and plugged it back in. Here's what you'd wind up with. By plugging it back in, I mean substitute. So we've got 6 here, plus 3 times 7, which is 21, and that's 27. I hope you guys can see that. I'll try to move this down just a bit for you. There we are. So substituting our value of w in for w, we do get the left side equal to the right side. We'll move to part C of this example. It's very similar to the other two. For this type of problem, we'll do the same thing. We'll use the distributive property. This one's a little tricky though. We need to make sure that the negative 7 here stays a negative 7. So we're going to take negative 7 and multiply it by x. That's negative 7x. And then this negative 7 and the negative 2 being multiplied together, and that's positive 14. 4x minus 7x is negative 3x. We'll still have 14 and then equal 26. Subtract 14. Negative 3x is equal to 12. Divide by negative 3. And x will be negative 4. If we substituted negative 4 back in, we'd have negative 16 here. And then inside we'd have negative 6 times negative 7, so that's going to be 42, I think. And if we add negative 16 and 42 together, we get 26. So this one checks out.